Good evening, dear students. Welcome to Competitiveness and Module 10, code FG 708. Today we are arriving to week number 10. As always, we have our topics here. The number one, that is calculating concentration of solutions. The number two, that will be different type of solutions. And the number three, that is examples of how to calculate different concentrations. You have my personal data at the bottom of this screen, and remember you uh, can subscribe to the course using this QR code for the Telegram group where I share all the information every week. Now let's continue with our class objectives for today. The first one, that is to learn concepts of different type of solutions and concentrations. The next one, that is distinguishing at least 6 main methods of solution concentrations. Then understanding how to use the methods of calculating the concentrations of different solutions. Now the last one, apply the knowledge acquired to everyday situations to solve real-life problems. Now, let's start with the next slide information that is here, the basic concepts. And with this, we're going to analyze some mixtures like the sample we see here. So we have two main types of mixtures. The first one, that is the homogeneous mixture. Example that can be like, for example, coffee, that is coffee plus water. Then some wine, that is a liquid plus liquid, or the air, that is a mixture of gas plus gas, or this musical instrument here, that is a compound that is made by a mixture of two metals, one solid metal plus one solid metal. It is the same for this tool here, or the natural gas. In this case, that is the gas, or maybe vinegar. That will be a mixture of liquid plus liquid, or the blood. That is the liquid that we have in our bodies. That is a mixture of different components that we're going to check on the next slides. Let's continue with this another type of mixture, that is the heterogeneous mixture, and some examples. So remember that we have two main types of mixtures. This one here, the heterogeneous, and the homogeneous mixtures. Okay. Here we see an example of solid plus solid. That is a salad here, solid plus solid. And here we have a mixture of liquid plus solid, And the last one, that is a mixture of gaseous state plus plus gas. But let's analyze more details about these types of mixtures, and let's check this mixture here. That is the air. I mean the components of the air. Let me turn on the fan first. Components of the air. This is a mixture that is made. This is a mixture that is made by some gas plus another gas. Let's say gas 1 plus gas 2 plus gas 3, and so on, and so on. Okay? So in this case, we have that the air is compounded by nitrogen with 78%. 78%. So here in this mixture, we are going to say that this will be the solvent. Okay, solvent. And then we have more gases here, like the oxygen with the 20.9%. That we're going to say that it is a solute. Okay, solute. Another gas like the this one here that would be another solute, or the argon here that will be another solute, and carbon dioxide, this one here, that will be also another solute. So when we say who is the solvent and who is the solute, okay, we are going to say that the let's say the material with the great amount will be the solvent. It will here because it is 78% of all the components. So we are going to say that this will be the solvent, and the rest of the components will be the solutes because they are in a lower amount. Okay, so this is the difference between the solvents and also between the solutes. Okay, so these are the main concepts here. Let's check more examples in order to understand these concepts here. So let's check this image here. In this case, we have a liquid here that is water. And we also have a solute here that is sugar. Okay, so water is the solvent and sugar is the solute. When we mix them together, we will get the sugar solution here, like this one here. So this is the mixture that is called solution. Okay. Now let's check another example here. If we have a solid like this one here, a solid like one here, and if we mix it with a liquid or solvent, we will get a solution. Okay? This is these are the main concepts that we are going to use while or during this lesson for today. Oh, let's continue. And let's analyze this example here, that is the blood. Remember that blood is the liquid that we humans have in our body. So we can see that blood blood is a mixture of different components like plasma, like these another elements here, and then we can divide these components like here plasma in other components like 1% or proteins 8%, water 91%, and the other division here is leukocytes here and platelets with 0.9% or erythrocytes with 99.1%. So this is an example of a different mixture that we have in our blood, remember? But now let's continue. Here we see that this man is making a mixture of some components, but we are going to see that in this case, this man is mixing a solid. Let me turn on the pen first of all. Solid, it is a mixture of solid plus another solid. Okay? While the next example, the next image here is a mixture of a liquid plus solids, okay? Solids. But now let's continue taking some images, additional images here. In this case, we have fruits here, fruits plus sugar, but we will say that this is a mixture of a solid plus solid. But in this case, we're mixing some fruits plus sugar. Fruits plus sugar, but solid plus solid. Let's check. Let's continue. Another example, like the previous examples, we see some mixture of liquid plus solids. Then we have this diagram here. Let's check. In this case, we see some sand here, plus water, and then we will get a heterogeneous mixture. Okay, heterogeneous mixture. But if we mix or combine sugar plus water, we will get an homogeneous mixture. Okay, so these are the different types of mixtures that we are studying today: heterogeneous and homogeneous. Okay? Two different types of mixtures. Now, how do we interpret percentage labels that we usually see in our daily life? Let's check. When we have a label like this one here, we can see that this information is like the next I'm going to explain here. If we have this battle, 10%, 10% of, I mean 100% of this solution, of this solution, it means that we can divide these components here with 80% alcohol, 80% alcohol plus 20% water. Okay, 20% water. Now let's check another label here with this image here. In this case, we have this 100%, 100% of solution, 100% of the solution that will be a 99.5% alcohol, like we see here, ethyl alcohol, and it means that only 0.5% will be, or it is water. So this way, we are able to interpret this type of information that we see over these bottles. So here we have another example with the sodium hypochlorite. That is 6% of the solute. 6% of the solute here, and 94% of water. Okay. Now, this is another example that says available chlorine 40%. It is 40%, 4%. I mean 4%, and the rest will be 96% will be water. Okay, we can analyze these tables here about some vinegar, some mixtures of vinegar, like this one here, that is 30% vinegar, 30% vinegar, and the rest and the rest, 70%, will be water. And you can see to your right the similar examples, but the difference is that it contains only 5% vinegar and the rest, 95% water. Now let's continue analyzing more information here that we need to learn, and we're going to know, we're going to see how to calculate concentration of some solutions. And we have this list of formulas here. The number one, that is a mass percent that we're going to write like this one. Just a minute. Mass percent, we're going to represent this with an M, this symbol here, percent. That will be mass absolute that we're going to write down like this one, divided by mass of solution, M solution here, and then multiply by 100. Okay, so we're going to use this formula here. Then we have the second formula, that is parts per million. And this formula, parts per million, will be equal to mass of solute divided by mass of solution, and then multiply by 1 million. Okay, but this number here represents 1 million. 1 million. Okay, it is equal to 10 power 6. So we're going to use this formula, like this one here. We're going to write these short notations here, like ppm, parts per million, equal to m solute divided by m solution and multiply by 10 power 6, that is the same that 1 million. Now let's check the next formula here, that is the mass divided by volume percent. And we're going to use this formula. So this M. In this case, M divided by volume percent equal to M solute divided by volume solution and multiplied by 100. Okay? Next, we're going to use another formula here, that is the volume percent. That will be equal to milliliters of solute divided by milliliters of solution and multiply by 100. We're going to we're going to use this formula using these letters here. V percentage equal to V volume solute divided by volume of solution and multiplied by 100. Then we have the formula 5 and formula 6, but we're not going to work with them, so no worries. We will not use those formulas in our lesson or calculations. Let's continue. Now we're going to explain some examples on how to use these formulas. Let's go ahead. And this is our first example here. Let me check. And we're going to use this formula that we saw before. We saw it before on the previous slides. And this problem says how many grams of solution. So the question here is this one, how many grams of solution? Oh, and it refers to how many grams of solution. It refers to this quantity here, mass of solution. There is 32.7% by mass of sodium chloride. It is salt. It is salt. Would contain 45 grams of salt. So 32%. This one here is here in our formula. Let's say 32.7% in our formula. And also we have the mass solute, that is here. This is the M solute. The M solute. And now we need to substitute our quantities into our formula here. So we will say that if we change the values here, we're going to see that we will have that 30.27% will be equal to mass solute. That is this one here, mass solute. In our formula, we'll say 45 grams divided by the M solution, but the M solution we don't know. We don't know who is this one. We don't know. So we're going to assign an X here because we don't know who is it. Divided by X. And then we need to multiply everything by 100. Okay? Now we need to clear the unknown quantity here and how we can do it. So we pass this X from right to left, we're going to do this, saying that it is dividing from the right. So we're going to pass this X multiplying to the left side of the equation. So we're going to do it this way. X multiplied by 32.7% will be equal to 40 40 grams multiplied by 100. But now we need to clear, let me change the color here. First of all, we need to clear our unknown quantity, that is this one. So this quantity is multiplying here, so we need to change this quantity to divide on the right side of the equation. So we're going to do it. Let me change it again. So we need to read this way. X will be equal to 45 grams, 45 grams multiplied by 100 and divided by 32.5%. If you use a calculator to make these operations here, we will get the result, and this x here will be equal to this one here, that is 138 grams. Yes, so this will be the mass of solution. And this is the answer of this problem here. But now let's go ahead with another example. In this case, we have this example that says how much solute is present in 756.1 milliliter of a 14.7% mass volume of this hydrogen chloride solution. So, first of all, remember that let me turn on the fan first of all. 1 liter is equal to 1,000 milliliters. Okay, 1 liter of a liquid will be equal to 1,000 milliliters, or it is the same that 1 liter will be equal to 1,000 milliliter. Okay. Now that you have seen these conversions here, let's work with this problem. We will going to use this this formula here that we had in our list of information so before. So in this case, they are asking how much solute. So if how much solute refers to this one here, let's say here. This will be our unknown quantity mass mass solution. Now, they gave us this one here, that is the let's say m divided b percent is equal to 14 14.7%, and the volume solution, volume solution, volume solution that is equal to let's check here 756 .1 milliliters. So now we have all our data, identified data, and we need to substitute all the variables here using these quantities and to solve the problem. So we're going to do it saying that 14.7% will be equal to the absolute, but we don't know who is this one here. We don't know, so we're going to write down x, and divided by the volume solution, that is this quantity here, so 756.1 milliliters. And then we need to multiply it by 100. Okay, so because we have this formula that says that it is that way. Now, we need to clear our x value here. So this quantity here is dividing and we're going to move this to the left right of the equation. So we will have like this here 756.1. Now we have the 40.7% here, and then it will be equal to x multiplied by 100. Okay, so it means that x, or unknown quantity, will be equal to 756.1 multiplied by 14.7%, and then we need to divide it by 100. But remember that we need to use this percentage value as 0.0 4, 7 without the percentage symbol. And then if you use a calculator, you will be getting this result here. 111 grams. That will be the answer of this problem. So unfortunately, I have no more time to continue with the class. We are out of time. So have a good night, and I'll see you on the next class.